will factor. Factoring is going to be the quickest way to solve that problem. So this one I picked because as I was looking through, I was like, oh yeah, that one will factor pretty easily. Parentheses right here. I would have an x and an x. I'm going to have a plus 2 and a plus 4. Okay, those aren't your answers. That's just your factored form. You've got to do x plus 2 equals 0, x plus 4 equals 0, which is going to give you negative 2 and negative 4 as your answers for that. So if a quadratic will factor, that's going to be the fastest way to do the problem. Some of these are not going to factor, but I can't remember which ones, and I'm not looking at the key right now. So let's say that you get one that you either, maybe it won't factor, or you just don't know how to factor it. Something that will always work is quadratic formula. So let's do number 10. I'm not sure if it'll factor or not, but let's just do that one. X squared minus 10x plus 26 equals 8. First of all, to solve any quadratic, you need everything to be on one side. So the first thing you would do, no matter what method you're going to use, is you're going to subtract that 8. So you're going to have x squared minus 10x plus 18. Yeah, I don't think that one's going to factor. So, quadratic formula, hopefully you guys know it. If you don't, memorize it. Negative b plus or minus square root b squared minus 4ac all over 2a. So, for this, your a is your number in front of your x squared. You don't have one, so it's a 1. So, our a is 1, b is negative 10, c is 18. So, to use quadratic formula for this, we would do opposite of b. So, since b is negative, it's going to be positive 10 plus or minus negative 10 squared minus 4 times 1 times 18 all over 2 times 1. And then you may use your calculator, but I don't want a decimal answer. I want the exact answer, which means you're going to leave it square root. So your answer might look like 2 plus or minus the square root of 7 over 5, right? So, so the calculator, you can use it to help you. I would not type the square root in. I would just do, be really careful here. I just never even put in the negative right here, because when you square something, is it going to be negative anymore? No. So if you do include that negative right there, you have to put parentheses around it like this. And you will get 28. Okay. If you don't put those parentheses, if you do this, negative 10 squared minus 4 times 18, you're going to get the wrong number because it's not squaring that negative. I just leave the negative off. I don't even put it in because I know that when I square it, it's going to be positive. So we get 28 underneath that square root. So x equals 10 plus or minus the square root of 28 over 2. 28 is not a perfect square, but will it break down? Not 6 and 4, 7 and 4. So I could make this 10 plus or minus 2 root 7 over 2. And then when you're reducing, you're looking at these 3 numbers. All 3 of those numbers have to reduce. 2 will go into them. So if we reduce here, we will get 5 plus or minus 1 times the square root of 7 all over 1, which if you want to write those ones, you can, but they're unnecessary, so the best way to write this would be 5 plus or minus the square root of 7. So some of these are going to require you to use quadratic formula. I'm going to show you one more thing. Let's turn over and do number 15. Okay, so we got 5k squared equals 60 minus 20k. And I'm going to try to convince, I'm not going to try very hard yet. We are eventually going to have to know how to complete the square. I like completing the square. I use it on a lot of problems, not all, though. I do not use it if I'm going to end up with fractions because it makes it harder to do. But if I'm not going to end up with fractions, I prefer completing the square because you don't have to simplify the radical at the end if you do it with completing the square. So I'm going to go over this. You should have completed the square before, but if it is foreign, you can always just use quadratic formula instead to solve these problems, which is fine for right now. Eventually, we're going to have to learn how to complete the square, but for right now, quadratic formula will do. But I'm going to throw this out here as an option for you and try to convince you that it's cool, because it is so cool. So, first thing, always, you got to move everything to one side. So, I'm going to move everything over here with that 5k squared so that 5k squared is positive. So, I have positive 20k minus 60. That will equal 0. If you want to complete the square, you cannot have a coefficient in front of your k squared. And actually, this is always an option. So even if you were going to do quadratic formula, it would be helpful on this one to divide everything by 5. So even if you're doing quadratic formula, you don't have to divide by 5, but you could. And in this case, since everything goes evenly, it is helpful there. So this. So even if you were doing quadratic formula, dividing through by that 5 would be helpful because now you would have smaller numbers to deal with. To complete the square, you're going to keep your k's over here. You're going to move the 12 over to the other side, that constant term. I'm going to put a plus blank here and a plus blank here. So our goal on this is to make this a square double square, right? So we want this to be like where we can write it as k plus something squared. So if this is a square double square, that means this middle number is the double. If I take half of it, it would give me the number that goes right here. So if I take that number right there, divide it by 2, it gives me the number that goes here. And so k plus 2 squared, if we square double square that, we would get k squared, we'd get 4k, and then for our square at the end, we would get a 4 right here. So what I did for that is I took this number right here, I divided by 2. That gave me this number. And then I took that number and raised it to the second power. And that went here. I should have done one where it was 4, where you get the same numbers there. But I can't just like add 4 to this side without also adding 4 to this side, because your equation has to stay balanced. So we're also going to add that 4 over here to the other side, which is going to give us 16. And so actually this one would have factored, I guess. Yeah, 6 and 2 would have worked. But we are going to square root both sides to solve this. Square root will get rid of that square. We'll have k plus 2 is going to equal plus or minus 4. When you square root both sides of something, you have to put a plus or minus. And then we can move the 2 over. So we get negative 2 plus or minus 4. And in this case, because I don't have any roots left, sometimes I have a root, I want to give my two answers. So I've got k equals negative 2 plus 4, which gives me 2. That would be one of my answers. And I would have k equals negative 2 minus 4, which would be negative 6. So that would be my other answer. Okay. So it's an option. I think it's a cool way to solve the problem. I actually could have factored that one if I'd solved. But you don't have to do that for sure. You could use quadratic formula instead, or in this case, you could have factored. How many are on that worksheet? Is it 28? 24? All right. For your homework, you must do 18 problems. And you've already done 3 of them. So really 15 more is what I need from that. So you may skip 6 for that. Any 6 that you would like. So let me get you your access code for your assignment, for your quiz. It's on Delta Math, so make sure you've got your Chromebook. You're going to go to Delta Math, and I'm going to give you the access code. It is ME5LP, I think. Yeah, LP. Okay, so you're doing quiz 3.1 through 3.2. Make sure you're doing the actual quiz, not the practice one. And your access code is ME5LP. And you have till the end of class. Please do your work on a sheet of paper, and I'm going to take that up because I might decide to give partial credit on this. So make sure you number your problems. So